Hello everybody, my name is Jürgen Broder and I'm going to present you my final project results as I was working on Elasticsearch as a scalable search and analytics platform. Working on big data sets is getting more and more important in the automotive industry, and that's why I decided to work on Geo-Spatial Queries. So how can I efficiently query geospatial information on big data sets which are initially stored in the Hadoop file system. I decided to approach the following architecture. So I'm going to use taxi data from New York City. I'm using the month of January 2015, and I'm going to provide this CSV file into an HDFS file system which is running on an Amazon Elastic MapReduce cluster. The file size is roughly 2 GB, and I'm going to take that file and to create an Hive table which is reading the data from HDFS, and in addition I'm going to create a second Hive table which is storing the data in the back in Elasticsearch. I'm going to use the Elasticsearch Hadoop plugin to transfer the data, and later on I'm going to do geospatial queries which I'm running on Elasticsearch using Kibana, and I'm also running these queries in Spark. Elasticsearch and Kibana I'm going to install on an Amazon EC2 instance. So let's have a look how these things are looking. I'm going to start with my presentation once I've creating the Hive table. So setting up the EMR cluster and the EC2 I'm not going to show in the video. If you're interested, check out my further report which is provided with our final project. So I've already connected to my master node of my Elastic MapReduce cluster, and you're looking at the shell currently. The first thing I would like to show you that I already uploaded my data into the Hadoop file system. So there is already the file which is called yellow trip data 2015-01 without header, and let's have a closer look what's inside there using the cut command. That's how my data looks like. So you see it contains timestamps, it contains geo information about pickup and drop-off points, and that's the data I'm going to work with. So the first thing I need to do now, as I'm using Hive tables, I'm starting my Hive environment. And the first thing I'm going to do in Hive, I'm adding the Elasticsearch Hadoop char to my class path. In my case, I've stored it on an S3 bucket, so I can use the following command, adding the char from my bucket. And what Hive is doing at the back, it's taking a local copy and providing this copy of the char to the class path. That char enables my communication with Elasticsearch. The first thing I'm now going to do, I'm creating a table which is reading the local CSV file stored in my directory user Hive taxi, the one that I showed you before, and I'm creating the table with exactly the same columns like the data is stored in the CSV file itself. So let's do this. My table has been created. The next thing I'm going to do is I'm creating a second table which is now stored in Elasticsearch. That's where the data is going to, and as table properties I'm giving the Elasticsearch node where my Elasticsearch server is running. The table structure is slightly different, as I need to concatenate the longitude and latitude values of the former table into one single column of this table, as it's needed later on for querying geo points. So let's create this table, and you see the table is being created. So finally, what I'm going to do in order to copy the data into Elasticsearch, I'm now going to do an insert override, and I'm selecting the relevant columns from my New York City taxi local table, which I created before, and I'm going to insert it into the New York City taxi, which I just created, which is going to store in Elasticsearch. So let's do this. And we are now going to see the Elastic MapReduce job, which is starting and which is in the back then copying my data. So let's now switch to Kibana and let's see if the data is already being received in Elasticsearch and if we can evaluate it already with Kibana. So I'm opening my Kibana page now, and currently I have no index pattern defined. So I created an index before which was called New York City Taxi, and I'm creating the index pattern now in Kibana. So it's recognizing that the index exists, and it's displaying me already the date time fields I can choose to create a time series. I'm going to take the pickup date as the time series, and I'm creating my index pattern. What you can see now, that all the data which is transferred in the back is ending up in a dedicated field in Kibana, and for me the most important point is that I got my pickup geo field, which is recognized as a geo point in Kibana. So the matching of my index I defined before is working. We can go now to the Discover page, and in the Discover page I have to switch to the last 5 years of data, or I could take the last 2 years as well, as I imported taxi data from 2015. And while I'm doing this, you can see that I already got some hits, and in the back my data is going to be loaded to Elasticsearch. So currently there are 2.6 million hits. If I'm now going to refresh the query again, you see that it's already 2.9. So while I'm recording the video, my MapReduce job is still running and is importing in the back the data to Elasticsearch. So let's start to query the data now. In order to do so, I prepared the geolocations of the John F. Kennedy Airport. I selected the geolocations of the terminals 2, 5, 7 and 8. And what I can do now, for example, I would like to query all pickup locations of the taxi rides which have been at Terminal 2. So that's the query I'm using for this, and I want all the pickups which are 100 meter around of the geo point I've defined there. That's how my query looks like. I can fire the query, and you see that I currently got more than 2000 hits matching that pattern. So while the data is still loading, let's start to visualize the data. I'm going to the Visualize page. Or let me do first, let's save this query and let's call it Terminal 2. And what I can do next, I can go to the Visualize page and let's create a bar chart based on that search. And let's assume we are interested in what's the best terminal to go for as a taxi driver. Where can I earn the most money? So I'm interested in the average of the fare amount. And as I started the query, or as I started the visualization based on my query for Terminal 1, that's all I need to do. But let's add 2 more informations. So let's say we are also interested in the average amount of passengers which are riding, and then let's apply these changes, and you can see that my average fare amount based on the data which is already loaded is roughly $47, and that there are an average roughly 1.7 passengers riding on that taxis. So let's do the same now for Terminal 7. I'm going to place my query for terminal 7, and I'm saving this query. I'm creating also a visualization for this one. I'm doing it from my terminal 7 query search I just saved, and I'm again interested in the average fare amount, and I'm interested in the average passenger count. So let's apply the changes, and I have the same bar chart here now. Let's save this visualization. And finally, let's go to the dashboard and make a dashboard out of it, where we can say, okay, terminal 2 and terminal 7, I'm interested in both. Let's make it a little bit bigger. Okay. And let's go to the table view. And then we can see at terminal 7 the average fare amount is more than $50, while on terminal 2 it's roughly $47. You still see the figures changing every 5 seconds as my data is still loaded into Elasticsearch. So finally we will have about 14 million entries, and the data is still loading. So let's now go into Spark and see how we can query the data from Spark. Okay, so you're now seeing again the shell of my Elastic MapReduce master node, and the first thing I'm going to do, I'm going to change the properties of my Spark shell logging, that we are just getting errors and that we can better watch the results of the queries we are doing. The next thing I'm going to do, I'm also providing the jar file of my Elasticsearch Hadoop adapter. I'm copying it to the local file system, again from my S3 bucket. It's available now. And the next thing I'm going to do, I'm going to start the Spark shell, and I'm handing over 2 parameters. So it should add the Elasticsearch Hadoop jar to the class path, and the second thing, it should set my Elasticsearch node to the IP address where my server is running. So let's start the Spark shell. So the first thing I'm going to do when the shell is ready, I'm importing my necessary classes, the Spark conf and also the Elasticsearch Spark. So let's do this. And the next thing I'm going to do, I'm creating a Spark configuration. So I call my application name New York City Taxi. Finally, or not, the next thing I'm doing for terminal 2, I'm creating an RDD object where I'm handing over my query parameters, and you can see again that I'm having the latitude longitude values, and I'm having this 100 meters around that geo position. So let's add it. And now I'm going to show you the first 5 lines of that object. And now in the Spark shell, finally my job is going to be executed. And in the back it's querying now Elasticsearch, and it's presenting me the results, the first 5 entries here in Spark Scala. Next, we can also count the objects in our RDD object, and we can see that currently we have more than 8,300 hits fitting that query. I hope you enjoyed my video. Thanks for watching, and if you're interested, check out the project documentation on Harvard. Thanks.